Hello children, in this video we are going to learn about standard 8th science unit number 3. Name of the lesson is light and numerical problem number 1. It is on page number 24. Okay, so our problem is the radius of curvature of a spherical mirror is 20 centimeter. Find its focal length. Okay, so radius is given and we have to calculate only its focal length. Spherical mirror's focal length we have to calculate. Let me move on to solution. So the first term, as we all know, given. So given is nothing but what are the values are given on the question. So here the values are given radius. Radius of curvature. Radius of curvature is given, that is 20 centimeter. Radius of curvature is 20 centimeter. Okay. So what we have to calculate? Find its focal length. So focal length will be the question mark. Focal length, that we can represent letter as small letter f will be the question mark. Radius we can write capital letter R. So radius is given, focal length we have to calculate. Okay. Our next step is formula. Our next step is formula. So we all know the formula. Focal length. Focal length f is equal to, the formula is radius of curvature. Radius of curvature. It is denoted letter is R divided by 2. The formula is focal length f is equal to radius of curvature divided by 2. Okay. Our next step, we have to substitute, or simply we can write as R by 2. F is equal to R by 2. Okay. And then we can substitute. Radius value is given on the question is 20 centimeter. So substitute 20 centimeter divided by 2. Divided by 2. So we can get cancel. 1, 2 is 2 and 10 2s are 20. So the answer is 10 centimeter. So the answer is 10 centimeter. So focal length is f is equal to 10. Focal length f is equal to 10 centimeter. That's all. Very easy problem. The first one we should know the formula. Focal length is equal to radius of curvature divided by 2. Clear children? Numerical problem number 2. It is on page number 24. So unit number 3 light. Numerical problem number 2, page number 24. Okay. So let's see the problem. The problem given is focal length of a spherical mirror is 7 centimeter. What is the radius of curvature? So focal length is given. We have to calculate radius of curvature. Okay. So let me move on to the solution. As we all know, the first what we are going to write is given. The given is nothing but what are the values are given on the question. So here focal length is given, that is 7 centimeter. So already we know in last video we have learnt about focal length f is equal to 7 centimeter. Focal length, the term equal to the given value is 7 centimeter. And we have to calculate radius of curvature. So next, radius of curvature. Radius of curvature denoted by the letters R will be the question mark. So focal length is given, radius we have to calculate. Okay. So let me move on to next step is formula. So formula, the previous question, the same formula, we know that focal length f is equal to radius of curvature by 2. So radius now we can know that is capital letter R. So simply I should write here f is equal to R by 2. So we have to calculate R. Clear? So it implies R is equal to, this 2 will go to the numerator. So 2 times of focal length. Clear? So f is equal to r by 2. So r is equal to 2 times of focal length. Then directly we can substitute. The value is given on the question is 7. So 2 times of 7. So 7, 2 times of 7. What will be the answer? 2 for 7 are 14. The unit is centimeter. That's all. So the answer is radius of curvature. Radius of curvature r is equal to 14 centimeter. That's all. The same formula. Focal length is equal to radius of curvature divided by 2. So that we can modify r is equal to 2 times of f. So the radius of curvature r is equal to 14 centimeter. Clear, children? Numerical problem number 3. It is on page number 28. Okay, so unit number 3, light numerical problem number 3. Okay, already we discussed 2 problems. Let me move on to third problem. The problem is, if two plane mirrors are inclined to each other at an angle of 90 degree. So see children, here 2 plane mirrors. So this is one plane mirror and this one another plane mirror. So plane mirror, it has a flat surface, reflective surface. So 2 plane mirrors to each other at an angle is 90 degree. So the angle exactly 90 degree. Okay. So that find the number of images formed. So what is our aim? To calculate find the number of images formed. So for this images we have to calculate. Now we should know the formula. So first step is given. As we all know, given. So given is 2 plane mirrors inclined to each other at an angle is 90 degrees. So we can write angle is given. Inclined at an angle is 90 degree. Angle we can represent the term is called theta. So angle we can write theta is equal to 90 degree. So see the question. The only one value 90 degree is given. That is 2 plane mirrors inclined to each other at an angle is 90 degree. So 90 degree. Clear? So we have to calculate, find the number of images. So what we have to calculate? Number of images. Number of images will be the question mark. Number of images will be the question mark. Okay. So the next step is formula. What is our next step? Formula. So formula is to calculate the number of images. So number of images is equal to 360 degree divided by theta. The formula is 360 degree divided by theta minus 1. 360 degree divided by theta minus 1. Okay, so what we have to do next? We have to substitute the given value. So the value is already given is 90 degree. So we can substitute 360 degree divided by 90 degree minus 1. Clear? So instead of theta, I can substitute the value 90. That's it. So first we have to divide it. So 0, 0 get cancelled. 9, 1 9 table, 4 9s are 36. So 4 minus 1. 4 minus 1, the answer is 3. Okay. So the number of images is equal to 3. If the angle is 90 degree, how many images are formed? The images is 3. Okay. So how 3 images are formed means, look at here. Here I can keep any one object. For example, any one man is standing. Okay. So you can see the image of this man, one from this mirror. So 1. And another one from here. So this is mirror number 1. This is mirror number 2. So one from mirror 1 and one from mirror 2. What about the third one? 3 images are formed, is there na? So where is the third one? Now here, the joining point here, the third images are formed. Okay. If you have any doubt, we can place it on the mirror like this. Look at this, we'll get 3 images. So the angle is 90 degree. Now you can get totally how many images? Number of images is 3. The formula is 360 degree by theta minus 1. Clear, children? Page number 30, numerical problem number 4. Okay. So the problem is, speed of light in air is 3 into 10 to the power 8 meter per second. Okay. And the speed of light in a medium is 2 into 10 to the power 8 meter per second. Find the refractive index of the medium with respect to air. Okay. So, speed of light in air is given and speed of light in medium is given. We have to calculate refractive index of the medium with respect to air. The first step, let me move on to solution. So, as we all know about first term is given. Given is nothing but what are the values are given in the question. So first one, speed of light. Speed of light in air. That we can represent as the letter is C. Okay. Speed of light in air, C is equal to 3 into 10 to the power 8 meter per second or ms minus 1. Both are same. And next, speed of light in a medium is given. So next step, speed of light in a medium. Medium we represents the term V is equal to 2 into 10 to the power 8 meter per second. Clear? So only two values are given. Speed of light in air and speed of light in medium. Okay. Then what we have to calculate? Refractive index. We have to calculate refractive index. Refractive index denoted as a letter is mu. Will be the question mark. Will be the question mark. Okay. The next step is formula. So first we should write the formula of refractive index. So refractive index, which is represent letter is mu, is equal to speed of light. Speed of light in air, that is C. Speed of light in air, that is C, divided by speed of light in medium. Speed of light in medium, which is denoted as letter is V. So simply we can write mu is equal to C by V. Mu is equal to C by V. Then we can substitute directly. C values are there. What is C value is? 3 into 10 to the power 8 meter per second. And V values are there. V value is 2 into 10 to the power 8 meter per second. Clear? So 10 to the power 8, 10 to the power 8 get cancelled. Both the units are get cancelled. So the balanced one is 3 divided by 2. So we can divide 3, 2, 1. So 1, 2s are 2. Balance 1. So here we can add 0 point. So 5 2s are 10. So the answer will be 0. So mu is equal to 1.5. So for this refractive index, we doesn't have any unit because both the unit get cancelled. So ratio we are calculating. So no unit. So refractive index. So the answer, refractive index, mu is equal to 1.5. That's all. Here simply only one formula. Refractive index is equal to speed of light in air divided by speed of light in medium. Direct substitute will get the answer. So the final answer is 1.5. Clear, children? Page number 31, numerical problem number 5. Okay. So the problem is refractive index of water is 4 by 3. Refractive index of water is 4 by 3. And the refractive index of glass is 3 by 2. Find the refractive index of glass with respect to the refractive index of water. See children, here two values are given. The one is refractive index of water. So let me move on to solution. So solution, first step is given. So given is nothing but what are the values are given? Refractive index of water. So I have written here refractive index of water. So we all know refractive index or symbol is mu. So water na we can represent W is equal to, what is the value? 4/3. That's all. Clear? The next one is refractive index of glass. The next one is refractive index of glass. Refractive index of glass, that is mu. Glass, so starting letter G, so G is equal to 3/2. So clear? Refractive index of water, mu W is equal to 4/3, and refractive index of glass, mu G is equal to 3/2. Okay. So then what we have to calculate? Refractive index. Listen. Refractive index of glass. So refractive index of glass with respect to refractive index of water. So with respect to not divided by refractive index of water. See children, refractive index of glass with respect to refractive index of water. So refractive index of glass with respect to refractive index of water will be the question mark. Okay, so this one directly we can write. That is how we can write now? Mu refractive index glass we have to calculate with respect to water. So W mu G is equal to refractive index of glass divided by refractive index of water. So in this one we have to substitute directly. So no formulas. Refractive index already given. So we have to calculate that ratio only. So we can substitute the value directly. So refractive index of glass value is 3/2. Refractive index of glass is 3/2 divided by refractive index of water is 4/3. Okay. So we can convert it. So 3/2 multiply by, so here both term will be changed. So 3 divided by 4. Okay. So 3 3s are 9 and 2 4s are 8. Clear? So we can divide it. 9 divided by 8. So 9 divided by 8. So 1 8s are 8. So balance 1. We cannot go. So point again 1. So 1 8s are 8. 2 0. So 2 8s are 16. So balance 4. Again we can add 0. 5 8s are 40. 5 8s are 40. So the answer is 1.125. 1.125. That is refractive index. That is refractive index of glass divided by refractive. That only we are going to calculate. So refractive index of water is equal to 1.125. Is equal to 1.125. Clear children? Simply we can write now mu G glass with respect to W is equal to 1.125. Clear children? So here there is no formula, already given values. We have to calculate the ratio. So first refractive index of glass with respect to refractive index of water. So we can divide initially glass divided by water. So we get cancel. We'll get the answer is 1.125. Clear children? Thank you.